Hello, 6th grade math students. This is chapter 9.2, length of line segments. We're going to learn to find the lengths of horizontal and vertical line segments on a coordinate plane, and then solve real-world problems involving coordinates and a coordinate plane. Let's get started. We'll start by finding the lengths of line segments AB, CD, EF, and GH. Let's begin with line segment CD. The coordinates of C are 3, 0, and D are 7, 0. By counting the number of units from 3 to 7, we can see that the length of CD is 4 units. 1, 2, 3, 4. So line segment CD has a length of 4 units. Coordinates of A and B are -4, 0, and 2, 0. Once again, we'll simply count the number of units from -4 to 2. 1, 2, 3, 4, 5, 6. So the length of line segment AB is 6 units. You can also find the length of AB in this way. AB equals point A plus point B. So AB will equal the absolute value of point A plus the absolute value of point B, which gives us, think way back to absolute value from earlier in the year, gives us 4 plus 2, which equals 6 units. Remember, length is always positive, even if the coordinates are in the negative section of the coordinate plane. Let's go on to EF. The coordinates for point E are 0, -8, and the coordinates for F are 0, 1. So just as we have with our other line segments, we're simply going to count the distance between -8 and 1. That'll be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So EF is 9 units in length. Once again, we can find the length of line segment EF by adding our points together. So EF can equal the absolute value of -8 plus the absolute value of 1, which will give us 8 plus 1, or EF equals 9 units. Now let's take a look at GH. Point G is at 0, 2. Point H is at 0, 5. We are 1, 2, 3 units apart, so line segment GH has a length of 3 units. Here are 6 practice problems for you to work on your own. Use graph paper or draw a coordinate plane on your notebook paper. Plot each pair of points, then connect the points to form a line segment and find its length. In this case, even if you can visualize it without drawing the picture, I want you to practice plotting these, drawing the lines, and counting the number of spaces between, just to get a good feel for how this works, even if you think you can visualize it without. Okay? Press pause while you work, and we'll have another idea when you return. Now let's find the lengths of line segments that are parallel to the x-axis or the y-axis. Let's begin by finding the length of segment RS. Segment RS joins the points R, which is at 2, 2, and S, which is at 6, 2. Since the y-coordinates of points R and S are the same, we know that RS is a horizontal line segment. Even if we couldn't see it drawn on the coordinate plane, we know by looking at its ordered pairs that the line is horizontal because the y-coordinates are identical. Okay, so let's figure out what the length of the line is using a simple formula. Line RS equals the absolute value of the x-coordinate of S minus the absolute value of the x-coordinate of R. Sorry, it didn't quite fit there. So we substitute into our formula. RS equals the x-coordinate of S is 6 minus the x-coordinate of R, which is 2. So RS is equal to 6 minus 2, or RS is equal to 4. Okay. That may seem like a roundabout way to solve it when you can simply look at the graph and count 4 spots. But if you don't want to graph it, using this formula allows you to find the difference without plotting, connecting the lines, and then counting the distance between the 2 points. Now let's look at segment MN. The line segment MN joins points M, which is at negative 5, 5, and N, which is at negative 5, 1. The x-coordinates of points M and N are the same, so that means the line is vertical. So if we're to write these out, we could see immediately by simply looking at the ordered pair that the x-coordinates are the same, or the x-points are the same, so this is a vertical line. Once again, we'll use that simple formula. Line MN is going to equal the absolute value of the y-coordinate of of M minus the absolute value of the y-coordinate of N. So MN is going to equal 5, the absolute value of 5, minus the absolute value of 1. MN equals 5 minus 1, or MN equals 4. So the length of line segment MN is 4 units. Let's take a look at this last line segment, PQ. Line segment PQ joins points P, which is at negative 3, negative 10, and point Q, which is at 6, negative 10. Since the y-coordinates of P and Q are the same, we know PQ is a horizontal line segment. So let's use that formula. PQ is going to equal the absolute value of the x-coordinate of P plus the absolute value of the x-coordinate of Q. Let's substitute in. X of P is negative 3 plus the absolute value of 6. PQ is going to equal 3 plus 6. Line segment PQ has a length of 9 units. Okay? Let's go on to practicing a few of these on your own. Try out these on your own. Use graph paper or draw a coordinate plane on your notebook paper and plot each pair of points. Connect the points to form a line segment and then find its length. You may draw a single coordinate plane and put all 6 points on it if you're able to make that work. There's no need to draw multiple coordinate planes. Press pause while you work. We have more to do after this. Let's now use what we've learned about plotting points on the coordinate plane to solve a real-world problem. A plan of a rectangular garden is shown. The side length of each grid square is 2 meters. So let's begin by giving the coordinates of points A, B, C, and D. Well, let's see. Point A is at 2, 12. Point B is at 2, 2. Point C is at 18, 2. And point D is at 18, 12. Now let's find the length and the width of the garden in meters. So first, what's the length of AD? Well, we can solve for that by taking 18 minus 2, correct? To get a side length of 16. BC will be the same. Now let's find the width of the garden, which would be AB. And we can solve for that by taking 12 minus 2 to equal 10. And CD will be the same length. All right, so now let's find the area of the garden in square meters. All right, remember area equals length times width. So now all we simply need to do is substitute. Our length is 16, our width is 10. Therefore, the area of our garden plot is 160 meters squared. Now let's finish up by finding the perimeter of the garden, which we can find by simply taking 2 times, I'm going to move up here and work in red, 2 times length plus width is going to equal our perimeter. So 2 times 16 plus 10, or 2 times 26, which will give us an answer of 52 meters. So our perimeter is 52 meters. Now it gets to be even more fun. Let's say there is a palm tree planted at point E in the garden at a distance of 12 meters from line AB and 4 meters from line AD. Let's figure out the coordinates of point E and then plot it on our coordinate plane picture of our garden. So the first thing we need to do is find out how many grid squares from AB point E is. Remember, our instructions tell us that point E is 12 meters from line AB. So that means it needs to be 6 grid squares away, right? Because each grid square represents 2 meters. So for point E to be in the garden, the x-coordinate has to be 6 units to the right of AB. Let's count that out. It would need to be 1, 2, 3, 4, 5, 6 away. So our x point is going to be at 14. All right. Let's go ahead and write that down. And then get rid of those marks. And now let's figure out where our y coordinate is going to be. All right, our question again tells us that our palm tree is 4 meters from line AD. So how many grid squares away will it be? It'll be 2 grid squares away. So our y coordinate has to be at 8, correct? Because that's 2 grid squares away from line AD. Okay, now we know our coordinates. Our coordinates are 14, 8. So we can plot our tree on our graph now. Let's do it. I'm going to go to 14x and up to 8y, and here is our tree, point E. Here's one final practice problem for you before we work together tomorrow on solving more problems like this. There's a graph picture here for you to work from. Question 13 asks you to please give the coordinates for points A, B, and C. In problem 14, let's say that Mr. Manning, who owns this yard, wants to build a fence around this plot of land. If BC is 25 meters long, how many meters of fencing will be needed to enclose the area? In question 15, I want you to figure out the plot point for a pole that's contained within this area. If the pole is located 10 meters from line AB and 5 meters from line AC, give the coordinates of the pole. Do your best with this. If you get stuck, no worries. We will go over this problem together tomorrow. I'll see you then to do more work with finding lengths of line segments and solving practical real-world problems. Have a great night.